Okay, what's with the numbers? Thankfully, in our safe learning environment, many members have been honest in expressing their confusion about numbers. It's evident that the basics of pitch are not understood in order to make sense of how the numbers work, or more accurately, how they represent steps and half steps, or tones and semitones. If you understood the structure, you might ask, why do consecutive numbers, 1 through 7, they're equally different by 1? Well, that's what they are, consecutive. How can these consecutive numbers represent consecutive scale steps that are not equally different? But the problem is, you're probably too baffled to formulate the question. So, let's look at it from a couple of other points of view, like from a piano keyboard's perspective. To help understand the piano keyboard, you need to understand this. 1. All keys or notes are created equal, black or white. Sound familiar? Kind of has a ring to it. 2. The distance from any note to the nearest neighboring note that it touches is 1 semitone, regardless of the color. Any note to the next note that it touches, its nearest neighbor, so the nearest neighbor, this white note, is this black note below it, lower in pitch by 1 semitone. The nearest neighbor above it happens to be white, and it's the same distance musically. If we had our backs turned and we don't have perfect pitch, thankfully, we wouldn't know the difference between that and this. Both went down by 1 semitone. These distances are all equal, even though they don't look it. From here to here is a semitone, and here to here is a semitone, and so on, semitone, 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 semitone. This is the nearest one that touches it. There is no difference between this semitone distance and this semitone distance. It takes 2 semitones to make a tone. So if that's 1 semitone from here to here, and this is another semitone from here to here, then from here to here is 2 semitones. 1, 2. And that distance is a tone. From here to here is a semitone, another semitone makes 2 more semitones, so from here to here is a tone. So these notes are a tone apart. I'm going up and down a whole tone scale. Every note is a whole tone, that is 2 semitones. Let's start here. From here to here is a tone. Here to here is a tone. Here to here is a semitone. Here to here is a tone. Here to here is a tone. Here to here is a tone. And the last one is a semitone, takes you back to where you started. So that is a C scale. And you can see by the shape of it, it is tone, tone, semitone, tone, 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 semitone. And if you know tone, tone, semitone, tone, 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 semitone, you can start anywhere like here. Okay. Tone, tone, semitone, tone, 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 semitone. So if all those distances are the same, why didn't they just make the piano go black, white, black, white? Well, they probably did. And it looked something like this. Oh, that's all fine and dandy, but now that you got to go play something, where are you going to start? You'd need sticky notes all over it to find your way around. And what would a major scale look like anyway on this piano? Well, we would start here, whatever the heck note that is. But let's say that's the 1st degree. That would be the 2nd degree of the scale. This is the 3rd degree. Why? Because from here to here is a tone. From here to here is a tone. But 3 to 4 is a semitone. So I'm going to limber it up here. I don't have a white pencil. That would be the 4th degree. The 5th degree is a tone away. Another whole tone, another whole tone, and back to 8, and 8 equals 1. 8 equals 1. Okay. So that's what your scale would look like on this piano. And by the way, it wouldn't matter where you start on a white note, it would always be 3 white, 4 black, and then the first white again. Weird, eh? So back to our real keyboard, we need to know that these are all semitones and tones and so on, regardless of the distance, because they sure seem just like the numbers 1, 2, 3, 4. They all seem equal and consecutive, but 3 to 4 is not the same distance. If you wanted to look at the ends of the notes, they all look the same distance apart. Or let's say without the black information there, you look up and down here, they're all equally spaced. They're all the same distance apart. But we don't know where's the semitone. We need to know. Oh, it's here. These two are physically the same distance apart. You can put 3 fingers on them equally, but they're not the same distance. This is only a semitone. From here to here is a full tone. You know, if you made a keyboard that had all the semitone distances exactly the same graphically, so you measure each line, it's the same distance between these semitones, it would kind of look like this. And then you got these spaces here where there isn't nothing, and maybe they did make something like this, and that's how it would look if all these semitone distances were the same regardless of black or white. Then you could say, oh, maybe they made a split in the middle of the key here like this and made the key come all the way to the edge like there and there. Well, we're getting back to what we got in the first place. So it's evolved quite naturally the way it should have. So we're going to accept the keyboard for what it is. And if you look at the back of it, this end of the keys, you'll notice that it really is pretty equal. Whether it's black or white, the distance from one semitone to the next is pretty equal. So we can actually use this to make our numbering system graphical and proportional. So let's use our C again. Let's use this one. It's really easy to understand that this would be the first degree of the scale. That's the 1. From first to second is a tone. This would be 2. This would be 3. 4 is here. 5 is here. 6, 7, and 8 equals 1. All right, so if that's the shape of our scale, what we know is takes 2 semitones. From here to here is a tone. From here to here is a tone. Here to here is a semitone. Here to here is a tone. Here to here is a tone. Here to here is a tone. And then semitone. So we have a structure of a major scale. Tone, tone, semitone, tone, 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 semitone. And we can put that structure wherever we want. Let's just slide the paper to a random note. Okay, there it is. Line it up with an A. Alright, so there's the 1. If we start there, a tone up is here, a tone up is here, the semitone is here, a tone, a tone, a tone, and semitone. We know A. We know any old A anywhere on the piano. Stick it wherever you like. Oh, what do you know? It's on a black note first. From the first note, that's our pitch pipe blow, the 2nd degree, the 3rd degree, the 4th is a semitone, the 5th tone, 6th tone, 7th tone, and 8th or 1, where we started, is a semitone. Tone, tone, semitone, tone, 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 semitone is all you need to know to make a major scale. So if we know tones and semitones on a guitar fretboard, we could make a scale. All we need to know is these frets are all the same distance apart, even though they look fatter down here and skinnier as you go up. That's just because when you shorten a semitone on a string that's only half the length, like from here up, these are half the distance that they are down here, because you're shortening them by a proportion, a percentage of its overall length. So these are actually all exactly equal. They're all semitones. So if we went anywhere, and we don't need to know note names, we can play any starting note. Let's say that's where we blew the pitch pipe. We'd have, that would be our starting note, up a tone, up a tone, up a semitone, up a tone, up up a tone, up a tone, up a semitone. So I used to joke with my students, get them to understand that on a different planet where the creatures had 3 toes, and they made instruments that had a chromatic scale that looked like this. So these are all, regardless of first, second, and third row, they're all a semitone apart. So do 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 do, and so on. So what would a scale look like? Well, it'd look like this. Here's your starting note. How far to the second degree? Tone. How far to the third degree? Tone. How far to the fourth degree? Semitone. Tone. 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 Semitone. And that's what the scale would look like. Tone, tone, semitone, tone, 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 semitone. So what's with the numbers? Yeah, they're unequal. We just have to remember that 3 to 4 is a semitone. 7 to 8 is a semitone. All the rest are tones. So why didn't they make it 1, 2, 3, make it graphic? This is actually 3.5. It's a half step. So 1 to 2 is a whole number, that would be a half step. Well, are you really sure that you want your scale to look like this in numbers? 1, 2, 3, 3.5, 4.5, 5.5, 6.5, and 7 equals 1? Yeah, no. Let's go with this. It's kind of worked. It's the only universal language. We just have to understand it. Oh, I know. Why don't we just do it in semitones as the basic unit? Okay, well then this is what you're going to get. Numbers are going to be 1, 3, 5, 6, 8, 10, 12, and 13 equals 1. Yeah. Just in case you didn't believe me. So what we're really saying is the numbers are just consecutive labels that are easier to keep in order than do, re, mi, fa, sol, la, ti, do. For example, can you go down the scale, that's backwards, just as easily? Let's find out. Ready? Starting with T, backwards. You got 5 seconds. Go. Yeah, that was beautiful. Now, backwards from 7, go. Okay, very good. That was 2 seconds. Now, going down, that's backwards, by 2s, starting with T, go. Now, going down, that's backwards, by 2s, starting with 6, go. Yeah, see? So, as you can see, the numbers have a more familiar order. They're not measurements like on a ruler, they're only labels in order.